With COVID-19 cases climbing around the world and here in Canada, including the first death in BC, researchers are racing to study the virus and how to stop it. Now, Ottawa recently announced millions in funding for this. Dr. Alison McGeer from Mount Sinai is one of the experts taking on the challenge. She is a senior clinician scientist at Sinai Health's Lunenfeld-Tannenbaum Research Institute and joins us now to talk a little bit more about the research and what we can expect over the next little while. Doctor, thank you very much for joining us this morning. We appreciate it.
Good morning.
What will your focus be? I mean, we're talking about the millions. You're looking at one aspect. What are you going to be studying?
So we're doing a combination of things, but I think the two important pieces of what we're doing, most important pieces are, first of all, we're asking whether this is a virus that you can get infected with by breathing it in. So for most people, that doesn't make a lot of difference. We know it's transmitted by close contact, but in healthcare, the difference between big droplets land on your face and small droplets you can breathe in mean a difference in how we have to protect healthcare workers. So it's actually a very difficult question to answer, and we're fortunate that here in Toronto at Sunnybrook Hospital, Dr. Mubareka has the expertise to be able to do that sampling and ask that question. So it doesn't help the community, but it'll be a big help to us in hospitals if we can figure out that question.
I mean, we need you, the frontline workers, healthy. Why is it so difficult to figure that out? Now, you're saying the influenza virus. We're not even sure about that. We're
not even sure about the influenza virus. Well, a piece of it is because most viruses can be transmitted in multiple ways. So sometimes you can stop transmission in one way, but it'll still be transmitted the other way. And figuring that out, you can't, for instance, set up an experimental system, right, in which I have COVID and you don't, and then we expose you to me, and we, maybe we tie your hands behind your back so you can't touch your face, right? So you can't do those kind of experiments. You have to do it by watching what happens to people and measuring the amount of virus in the air in different sized particles, and that has just turned out to be really difficult. Easier now than it was because people have developed the technology to measure viruses in air. That's one of the big differences, and one of the things that will help us with understanding influenza later. So one of the other good things about what we're doing is it'll get us a lot more experience with looking for viruses in the air and measuring them, and that will actually help us later with influenza, which is important too.
Now, are other researchers doing this? Are you going to be working together with researchers around the world to try and figure this out, or are you just on your own on this?
So it's really interesting. Canada, in this particular circumstance, has moved much more quickly than many other countries. It's been amazing to watch the degree of organization within the Administration of Research in Canada and the Canadian Institutes of Health Research and the government to try to move this forward. So we're actually ahead of most other countries in deciding what we can do. And yes, we will. All of us who are doing pieces of this will be watching what other countries are doing, because the goal here is to make sure that what we do is complementary and that we're not duplicating. You do want a little bit of duplication when you're doing scientific experiments. It's always good to have two different people doing them. Make sure you get the right answer, but you want to be minimizing what you're doing. That's one of the things that CHR and the government has tried to do, is tried to make sure that what we're doing in Canada is where we can make the best contribution to the globe, right? It's not really about what happens in Canada, but what happens to all of us.
It's everybody, right? Is this all this, you said we're being quick to our response, is this all stemming from SARS and what we learned from that?
Yes, a lot of this is SARS, but also the H1N1 pandemic. But yes, very clearly, this is something that we committed to do after SARS, to not just with the health response or the public response, but that we could design a research response that would be able to get us the information we needed as quickly as possible. Be nice if you could have it yesterday, but if we can't do that, how quickly can we get it organized? Because when you're facing a new virus, there's a huge list of questions, things you don't know, that you need the answer to if you want to respond in the best way.
Is this something we should expect to live with? This is not going away. It's going to be like the flu.
Well, we don't know what it's going to look like in the long term, but certainly in the short term, in the next 18 months, this is a virus we're going to have to live with. It's not. We were extraordinarily lucky with SARS that when it was transmitted, when people were ill, and how long it took to pass from one person to the next, allowed us to control it with public health measures. And that gave us a little bit of the expectation that we might be able to do it again. But the truth is, this is a very different virus, which is a good thing. Okay, SARS was actually much more dangerous. This is a regular respiratory virus, and what we've learned is you cannot control its transmission. You can slow it down, which is part of what we're doing now, but we're not going to be able to stop it. So now, it might be one of those viruses where if you get infected once, you're immune to it and it's over, and then we can stop worrying about it. Or it might be like other respiratory viruses where you don't get completely immune to it and it comes back year after year. We're just going to have to wait and find out.
Is a vaccine a realistic option? Do you think we can see one in the next little while?
The minimum time to vaccine is probably 18 months. So there's one of the big pieces that the Canadian government is funding is work in Canada into vaccines, and that's going on in many other countries as well. I think vaccines are hard. There's reason to hope that we might have a vaccine, and if we do, people will be moving it as quickly as possible, but there are timelines that you can't get past. You know, in Ebola, we went from a prepared vaccine, right, one that we knew was ready, into a phase 3 trial in about 6 months. That was a miracle, okay? The problem here is we don't have that vaccine ready to go. So we know there's a 6-month minimum lead time after the vaccine is ready to go, and it's probably at least a year before we have that vaccine ready to be put in somebody's arm.
So we should really be prepared to be living with
COVID-19. We're going to have to live with this for at least 18 months.
Okay. Dr. McGirr, thank you very much for joining us this morning.
Pleasure.
Appreciate you coming in. And for the latest on the coronavirus updates, head to citynews.ca/topic/coronavirus. Let's head out to Mel now.